What is an allotrope?
Different arrangements of atoms of a single element, e.g., diamond and graphite are allotropes of carbon.
What chemicals are produced on the largest scale?
In terms of volume, not profit, sulfuric acid is the largest chemical produced worldwide. Global consumption is around 200 million tons per year, a number that is just too impossibly large to imagine. Nitrogen, N2, ethylene, CH2CH2, oxygen, O2, lime, mainly CaO, and ammonia, NH3, round out the top 5, though sometimes these change.
How does mass spectrometry, MS, work?
The purpose of mass spectrometry is to ionize a chemical sample, causing it to fragment, and to characterize the mass of the fragment ions that form to gain chemical information about the sample. The first thing that happens is that the sample molecules need to be ionized. And this is done by removing an electron from the sample to yield a positively charged species. Once ionized, a sample of molecules will typically fragment in a characteristic way. The ions that form, whether they are fragments or the original ionized species, are accelerated and then deflected in a magnetic field. Ions of different masses are deflected by different amounts. And this is how the masses of the different ions are distinguished.
Is it good to drink chocolate milk after a workout?
Yes. Milk contains a significant amount of protein, roughly 8 to 11 grams per cup. It is often recommended to consume 15 to 25 grams of protein after a workout session. So drinking 2 to 3 cups of chocolate milk would meet this suggested quantity. In comparison to regular milk, chocolate milk has about twice as many carbohydrates, which is good for soothing sore and tired muscles. Of course, it also serves to rehydrate your body from the water lost during the workout. Moreover, milk provides you with nutrients like vitamin D and calcium.
Why did Aaron Klug, United Kingdom, win the Nobel Prize for Chemistry?
For his development of crystallographic electron microscopy and his structural elucidation of biologically important nucleic acid-protein complexes. Klug expanded on the existing technology of electron microscopy to develop an approach based on mathematical processing of the images that gave higher contrast images at relatively low radiation doses and without having to apply heavy metal stains to the samples. His approach made it possible to determine the structures of important aggregates that would have previously been difficult or impossible to accurately characterize.
What is a phase boundary?
The interface between two phases, e.g., solid-liquid, liquid-gas, or solid-gas boundary.
What is Beer's law?
Beer's law tells us how the amount of electromagnetic radiation absorbed by a sample is related to the concentration of the absorbing species. Beer's law tells us that the absorbance is equal to the length of the sample, L, times the concentration, C, of the absorbing species in the sample, times the molar absorptivity coefficient. In this equation A is absorbance, which is defined as the negative of the logarithm of the ratio of the intensity of light passing through a sample to that incident on it. Basically, this gives us a measure of how much light a sample is absorbing and how much light is passing through it.
What is work?
A force acting over a distance, such as a person lifting a box.
What is a nucleotide?
Nucleotides are one of the basic units for another class of biomolecules, the ones that join together to form your DNA and RNA. The long names for these are deoxyribonucleic acid and ribonucleic acid. DNA and RNA are the macromolecules that store the genetic information in your body. A nucleotide consists of three parts: a nitrogenous base, a sugar, and a phosphate group. The identity of the nitrogenous base determines which letter in the genetic code is associated with the nucleotide, while the type of sugar determines whether the nucleotide is a ribonucleotide or a deoxyribonucleotide, which essentially just tells us whether it's going to be a part of RNA or a part of DNA.
What will happen to the gum I just accidentally swallowed?
When you were a kid, your parents or teachers probably told you, or at least they told us, not to swallow your chewing gum because it would take years to digest. Actually, your body can do just fine with digesting the flavor components, sugars and sweeteners, and softening ingredients in chewing gum. It's only the gum base that you cannot digest. However, just because you cannot digest it does not mean it will stay around in your body for several years. The gum base will just typically pass through your digestive system in just a few days' time. but please don't try to swallow a bunch of gum at the same time. Though it can get stuck and cause all sorts of problems.
What is stevia?
Stevia is a commercial name for an artificial sweetener and is also the common name for the plant that it is extracted from. Steviol is the basic structure of this class of sweetener, but when sugar molecules are attached to steviol, making it steviol glycoside, its sweetness skyrockets to hundreds of times that of regular sugar. This sweetener has been in use for centuries in South and Central America and in Japan since the 1970s. In the United States, it's only been available for a few years as a purified compound. Marketed under the name Trivia, raw plant extracts of the stevia plant are not approved for use in the United States.
How do planes stay in the air?
Airplanes are very heavy, so the force required to balance gravity and keep them in the air must be large. The engines propel the airplane forward, but we need to understand what gives the upward push or lift necessary to keep the plane in the air. This lift comes from the shape of the wings, which are typically curved on the top and flat on the bottom. This design requires air to flow more rapidly over the top of the wings than over the bottom, which creates a lower air pressure above the wing than below. The lower air pressure above the wing is what lifts the plane off the ground and keeps it in the air. This is commonly referred to as the Bernoulli Principle. If you blow across the top of a sheet of paper, you will see it lift into the air for the same reason.
Are all crystal lattices cubic? In other words, are all the three axes of the unit cell always the same length?
No. In fact, cubic is only one of the 7 crystal systems. These systems are based on the lengths and angles of the unit cell. The cubic group has 3 sides of equal length, and all the internal angles are 90 degrees. If one side is longer, we get a tetragonal lattice. If all 3 sides are different lengths, the lattice system is called orthorhombic. If one angle is not 90 degrees, it's monoclinic. If the angles are all equal but they're not 90 degrees, it's a rhombohedral lattice. If the angles are all different and not 90 degrees, the lattice is triclinic. Yes, you're right, that's only 6. The 7th isn't based on a cube at all. The hexagonal lattice system is, you guessed it, based on a hexagon.
What is resonance?
A way of describing the delocalization of electron density in a molecule.
What is charcoal?
Charcoal is made of carbon and ash and is formed when water and other substances are removed from animals or plants. It can be produced by heating wood or other biologically derived materials in the absence of oxygen.
What chemicals are used to preserve food?
There are two main types of food preservatives: those that prevent oxidation and those that prevent bacteria or fungi from growing. The first are appropriately named antioxidants, and these molecules work by reacting with oxygen themselves. Unsaturated fats are common targets of oxygen, which causes foods to become rancid. Antioxidants provide an even easier target for oxygen to attack, preventing O2 from wreaking havoc in other ways. Natural antioxidants include molecules like ascorbic acid, vitamin C. And there are also many unnatural antioxidants on the market. The second class of preservatives are those that stop the growth of bacteria and fungi, like mold, from growing. Many of these preservatives are acidic molecules that can be absorbed into the cells of bacteria. If enough acid gets into the cell, basic biochemical functions, specifically fermentation of glucose, slow down enough that the cell dies, and your food stays fresh.
How long does it take a chemical reaction to reach completion?
The length of time it takes a reaction to run to completion can range from a fraction of a second to thousands of years. It all depends on how large the energy barrier is for reactants to convert to products. If it's a simple acid-base reaction, like the addition of an HCl solution to water, the reaction will proceed almost instantly. Other reactions can be slower, such as the rusting of a car door. What you first notice as a small spot of rust could take years to spread over the rest of the door. Other reactions can be even slower yet. For example, the slowest biologically relevant reaction known in humans is estimated to take about 1 trillion years in the absence of an enzyme to catalyze it. That's longer than scientists believe the universe has even existed. Fortunately, enzymes have evolved that allow this reaction to take place in only a few milliseconds.
How do chemists purify compounds?
A few of the most commonly used purification methods are chromatography. See following question: recrystallization or extraction methods. These methods typically exploit a difference in how a property, like polarity, for example, of one chemical species causes it to interact differently with the surrounding material than the others from which it is being separated.
What is an unimolecular reaction?
A reaction that takes place involving only a single reactant molecule. There can be one or more product molecules formed.
What is a free radical?
A free radical is an atom or molecule that contains unpaired electrons in one, or more, of its orbitals. Typically these species will be highly reactive as the unpaired electron, s, can pair with other electrons in a favorable manner. Radical species can have any charge or be neutral.
What's in paint?
There are three main ingredients in paint: binder, solvent, and pigment. Binder is the stuff in paint that forms an adhesive so that it sticks to the wall. Unlike glue, it's not a polymer in paint, at least not a fully formed one. But instead monomers or short polymer chains that react, cross-link, to form larger polymer networks as the solvent evaporates. The solvent in paint is there to make the paint solution the right thickness so that you can easily put it on the wall without it dripping all over the floor. Then the solvent evaporates, driving the formation of the cross-linked polymer networks. Pigments are, of course, used in paint so that not everything is painted white. Though white paint still needs pigments to be white.
What is the law of definite proportions?
The law of definite proportions says that a substance always contains the same proportions of each element of which it's composed. For example, a molecule of water, H2O, always contains 2 hydrogen atoms for every oxygen atom. This is commonly understood among modern chemists. But it was an important step in working toward a microscopic understanding of the composition of matter. The first to make such claims, in the early 1800s, was the French chemist Joseph Proust. It was a controversial idea at that time. And other chemists believed that elements could be combined in any proportion.
What is glue?
There are many different types of adhesives. But you're probably thinking of that white glue you had as a kid. This type of glue is known as a drying adhesive because it hardens by evaporation of a solvent. In the case of white glue, the solvent is water and the sticky stuff that gets left behind is polyvinyl acetate.
What is isothermal?
With constant temperature.
Why did Henry Taube, United States, win the Nobel Prize for Chemistry?
For his work on the mechanisms of electron transfer reactions, especially in metal complexes. Taube investigated a series of ions of cobalt and chromium, finding that certain species reached chemical equilibria in solution, while others did not. A careful series of experiments demonstrated that, in some cases, a bridge was required to form between a pair of metal ions, or one of their ligands, before electron transfer could take place. In other cases, electron transfer could take place at a distance. These observations turned out to have important applications for many chemical processes, particularly in the field of biochemistry. It is also noteworthy that, at the time he won the prize, Taube had already established a strong history of being the first in the entire field of chemistry to report significant discoveries that were of great importance to the field. His importance to the field of coordination chemistry was recognized by the Nobel Committee. And the following quote is from one of their reports: "There is no doubt that Henry Taube is one of the most creative research workers of our age in the field of coordination chemistry throughout its extent. He has for 30 years been at the leading edge of research in several fields and has had a decisive influence on developments."
Where was early chemistry developed?
While many civilizations learned how to make dyes and pigments, or ferment fruit into wine, the earliest theories about atoms and what makes up the chemical world came from ancient Greece and India. Leucippus in Greece and Kanada in India both came up with the idea that there must be a small, indivisible part of matter. The Greek word for uncuttable is atomus, clearly the root of the modern term atom. Kanada's term for this similar concept was paramanu, or simply anu, the indivisible element of matter.
What are the potential dangers of nuclear energy?
The main risks associated with nuclear energy have to do with health hazards of radiation poisoning. This isn't the same type of radiation we're talking about with light and microwaves. That type is electromagnetic radiation. The radiation associated with nuclear energy involves subatomic particles, like neutrons, given off from nuclear decay processes. Exposure to this type of radiation can cause cancer or genetic defects, among other problems. Since the fission processes used to generate energy are normally well controlled, though, nuclear energy is generally one of the cleanest energy sources available. Nuclear reactors only become dangerous in the event of a meltdown or other disaster. But the chances of these happening are extremely small. Modern nuclear power plants are built with a series of fail-safes such that a series of multiple extremely unlikely events would have to happen, one after another, for a meltdown to occur.
Why does bleach kill everything?
The active ingredient in bleach, sodium hypochlorite, NaOCl, has a few ways of killing off microbes. One method involves causing particular proteins in the microbes to unfold, preventing their normal function and eventually killing the bacteria. Alternatively, bleach can disrupt the membrane that forms the outer shell of a bacteria. Since most bacterial membranes are very similar, bleach is very effective against a whole host of different types of bacteria. The human body actually produces hypochlorous acid, HOCl, itself to combat bacterial infections.
How are plastics sorted for recycling?
The first step in recycling plastics is to sort the plastics by their resin type, or resin identification code. The resin identification code is a number assigned to a plastic product or container, according to the type of polymers it is made of. While it was once common to directly use this code to identify the types of polymer, present, there are now other methods, such as near-infrared spectroscopy or density sorting approaches, that are used to sort mass quantities of plastic samples for recycling. See Polymer Chemistry for more information on resin identification codes.
Can cold weather really cause a cold?
This actually is not true. Colds are caused by a virus that must enter your body to cause cold symptoms. Contracting the cold virus really has nothing, directly, to do with cold weather. The only reason colds seem to be more prevalent during colder seasons is that people spend more time indoors, placing them in closer proximity to one another, which makes it easier for the virus to spread between people.
What is a quantum number?
Values of conserved quantities in a quantum mechanical system. Electrons are described using four quantum numbers, n, the principal quantum number, L, the azimuthal quantum number, ml, the magnetic quantum number, and ms, the spin quantum number.
Why was gold chosen as a form of currency rather than any other element in the periodic table?
What a neat question. There are very basic attributes to money that made gold the obvious element. The element should be a solid at all temperatures it might encounter over the course of its lifetime. No one wants their money to boil away on a hot day. The element needs to be very stable. We wouldn't want our coins rusting, bursting into flame, or slowly giving off radiation. And finally, the element needs to be rare, but not too rare. After you remove elements that don't fit these parameters, we are left with rhodium, palladium, silver, platinum, and gold. Rhodium and platinum weren't discovered until the 19th century. So they weren't an option for ancient civilizations. The furnaces of the ancient world couldn't reach the temperature required to melt platinum. 3,200 degrees Fahrenheit, 1,800 degrees Celsius, so it couldn't be made into coins. That leaves silver and gold. Gold has a lower melting point than silver and it doesn't tarnish in air like silver does, making it the clear winner for a currency element on our planet.
What is kinetic energy?
Kinetic energy is the type of energy associated with the movement of an object. Faster moving objects have more kinetic energy, and the kinetic energy of an object is related to its mass, m, and velocity, v, by the equation, E equals 1/2 mv2. This tells us that, for example, if we have two objects of equal mass and one is moving twice as fast as the other, the faster moving object will have 4 times the energy of the slower object. In this illustration, a horse pulls a pendulum into a position where it is about to be released to swing freely. Before it is released, the weight at the end of the pendulum has potential energy A, and when the pendulum is in full swing, it has kinetic energy B.
Why did Roger D. Kornberg, United States, win the Nobel Prize for Chemistry?
For his studies of the molecular basis of eukaryotic transcription. In order for DNA to be read for the purpose of producing a protein, there are a couple of key steps that must take place. Kornberg received the prize for his work to elucidate the details surrounding the first key step, transcription. Transcription involves making a copy of the DNA, which is to be transferred outside the nucleus of the cell. Interestingly, Roger Kornberg's father, Arthur Kornberg, also received a Nobel Prize in Physiology or Medicine in 1959 for his work studying how information is transferred from one DNA molecule to another. Who would have thought that his son would go on to win a Nobel Prize for a very related piece of research?
What properties influence solubility?
The most significant properties are intermolecular forces and temperature. If there are favorable interactions between the solute and the solvent, solubility will be higher. This is actually a balance of the interactions of the solute with the solvent and the stability of the solute in the solid phase. Temperature also influences solubility, and for most substances, solubility increases as the temperature of the solvent rises.
What is the basic structure of an amino acid?
The basic structure of an amino acid is shown below. Each amino acid has an amine, NH2, group, a central carbon atom known as the alpha carbon, a side chain, denoted R, and a carboxylic acid, COOH, group. The amine groups and carboxylic acid groups of amino acids can be joined in a chain to form polymers of amino acids, known as peptides. Two amino acids form a dipeptide, three form a tripeptide. And chains of 4 or more amino acids are commonly referred to as polypeptides. Long polypeptides fold into specific conformations, which is what makes up a protein.
What is diffusion?
Spreading of something more widely, the movement of a substance from an area of high concentration to an area of lower concentration. The scattering of waves through a space or an object.
What is a nucleus?
The center of an atom, consisting of positively charged protons and neutral neutrons.
What is iron smelting?
Smelting is a method for extracting a pure metal from an ore. An ore is a rock made up of metals and other minerals. In smelting, a chemical transformation may be used to purify the metal by changing the oxidation state of metals in the ore. We'll get into more detail on what an oxidation state is later in the book. The smelting of iron dates back to ca 1000 BCE, or maybe even earlier. And it typically involves first heating the raw material in a furnace called a bloomery. This produces a soft iron material that can be shaped. A hammer is often used to remove other impurities from the soft metal, before allowing it to harden to form a relatively pure form of iron.
What is the hardest material that has been discovered?
At some point you may have heard that diamond is the hardest material known to humankind. While diamond is extremely hard, there are actually a few materials that are even harder still. Years ago, some synthetically produced nanomaterials were discovered that are even harder than diamonds. Even more recently, 2 additional naturally occurring materials, both of which are even harder yet, were discovered. These materials are wurtzite boron nitride and a mineral called lensdelite. Wurtzite boron nitride has its atoms arranged in a very similar structure to the arrangement in diamond. But they are just different atoms, boron and nitrogen, rather than carbon. The other material, lensdelite, is actually also made from carbon atoms. But these are arranged differently from those of diamond. Lensdelite is also sometimes called hexagonal diamond and can be formed when meteorites, which contain graphite, hit the Earth at very high speeds. Wurtzite boron nitride is produced naturally at high temperatures and pressures during volcanic eruptions. To date, there are only small amounts of either of these materials that have ever been found or synthesized.
What is the melting point?
Temperature at which liquid and solid phases coexist in equilibrium.
What are metamaterials?
A metamaterial is a type of artificially engineered material that typically features a pattern or periodic arrangement of a material. Metamaterials are characterized by the fact that they take on specific macroscopic physical properties based on their structure or the pattern in which the material is arranged, but not necessarily the composition of the material. Another way to say this is that the elemental makeup of a metamaterial is not as important as the internal structure of the metamaterial. By relying on the structure of the material to influence its properties, metamaterials have been able to achieve properties that haven't been achieved in other types of materials. One example includes materials with a negative refractive index, see physical and theoretical chemistry, which have been able to achieve the first demonstrations of invisibility cloaking over certain wavelength ranges. And this technology will hopefully continue to progress as time goes on.
Why did Alan J. Heeger, United States, Alan G. McDermid, United States/New Zealand, and Hideki Shirakawa, Japan, win the Nobel Prize for Chemistry?
For their discovery and development of conductive polymers. This prize was awarded for the discovery of plastics/polymers that can, under certain circumstances, be made conductive. This was quite a surprising result, since nobody ever expected plastics to be conductive materials. These plastics/polymers consist of chains of conjugated carbon-carbon double bonds. In other words, carbon-carbon double bonds that alternate with carbon-carbon single bonds. These polymers were also doped, which means that electrons were either removed or added artificially by oxidation or reduction.
How are transition metals important in photosynthesis?
Chlorophyll, the green pigment that plays a crucial role in photosynthesis, contains an atom of magnesium at the center of its porphyrin ring. A porphyrin ring is an organic ring molecule found in many biochemical systems. The Mg atom plays a crucial role in the absorption of light from the sun, the energy from which is then channeled through the molecule and is eventually put to work by the plant's cells.
What does the city of Miletus have to do with chemistry?
Miletus, one of the Greeks' greatest cities, was located on the western coast of what is now Turkey and was home to where some of the earliest ideas about chemistry were recorded. During the 6th century BCE, the Milesian school of thought was founded, and the musings of three philosophers survived into the modern era: Thales, Anaximander, and Anaximenes. Thales thought the most basic building block of the universe was water and that the earth floated on top of this celestial water. Anaximander challenged both of these ideas, proposing that the universe was born when fire and water, or hot and cold, separated from one another and that the earth simply floated on nothing.
What is a sugar?
Sugars are part of a class of biomolecules called carbohydrates that are made up of carbon, hydrogen, and oxygen atoms. The simplest sugars are called monosaccharides. But, like amino acids, they can polymerize to form disaccharides and oligosaccharides. Sugars can usually exist in either a ring form or an open chain form, as shown in the picture below. The sugar in this picture is called glucose, which is the sugar most commonly used for energy in the human body.
What is a nuclear chain reaction?
A nuclear chain reaction is a string of reactions that occurs when a given nuclear reaction causes, on average, at least one more nuclear reaction to take place. Such chain reactions are important for the generation of nuclear power and also for nuclear weapons. Uranium-235 is responsible for the chain reaction that generates power in nuclear reactors and in some bombs as well. Uranium-238 is the more common isotope, so it is typically necessary to first enrich the uranium to be used in the 235 isotope. When a neutron collides with uranium-235, it generates uranium-236, which then undergoes fission to release energy and further neutrons that can collide with other uranium-235 atoms, causing the chain reaction to continue.
Why did Richard Martin Willstetter, Germany, win the Nobel Prize for Chemistry?
For his researches on plant pigments, especially chlorophyll. Willstetter was a German organic chemist who studied a variety of pigments isolated from flowers and fruits. He was the first to show that chlorophyll was a mixture of two different compounds, known today as chlorophyll A and chlorophyll B. These two molecules absorb slightly different wavelengths of light, so that the plant can capture more of the sun's energy.
What is a titration?
A titration is a laboratory technique used to determine the concentration of a species in a solution. This is achieved by adding a second species of a known concentration, the titrant, that will react with the species whose concentration is to be determined, the analyte. There must be some indication of when the titration is complete, or, in other words, there must be some indication of when the unknown species has reacted completely with the titrant. A common example is the titration of a base by an acid. In these cases, a small amount of a pH-sensitive colored indicator can be added, and the end of the titration can be determined by observing a sudden large change in pH via a change in the color of the solution.
How strong are intermolecular interactions relative to a covalent bond?
Most intermolecular interactions are fairly weak relative to a covalent bond. Covalent bonds typically involve energies on the order of 100 kilocalories per mole. A unit of energy commonly used in chemistry. Van der Waals interactions are the weakest type of intermolecular interaction with typical energies of roughly 0.01 to 1 kilocalories per mole, or 0.01% to 1% the strength of a covalent chemical bond. For a pair of interacting atoms, the strengths of ion-ion and ion-dipole interactions can vary widely, particularly in solutions, because the ions and/or dipoles can be separated by very different distances. The charges of ions can also be significantly shielded by solvent molecules around them. If the ions are very close together, like in a solid, their interaction energy can approach, or even exceed, that of a covalent bond. Hydrogen bonds are usually the strongest type of intermolecular interaction with energies of about 2 to 5 kilocalories per mole, or roughly 2% to 5% the strength of a covalent bond. Because they are such strong interactions, hydrogen bonds can play a dominant role in determining the structures of liquids, solids, and single molecules.
Why does ice float?
Ice floats in water because it is less dense than water, though this is actually a very unusual case in terms of comparing the densities of the solid and liquid phases for a given substance. Most substances increase in density when moving from the liquid to the solid phase of matter, but H2O does the opposite. When water freezes, it forms a network of hydrogen bonds between H2O molecules. And because of the spacing of the molecules in this lattice, ice is less dense and floats in water.
Is NMR the same as MRI?
MRI, or magnetic resonance imaging, is based on the same principles as NMR spectroscopy. While NMR is typically used to investigate problems related to chemistry and physics, the goal of MRI is to image nuclei in living things. This is accomplished in a way similar to how an NMR spectrum is collected, except that the applied magnetic field has a gradient, meaning the field strength is different in different parts of the sample being imaged, usually human or animal tissue. This allows the use of microwave radiation to excite nuclei in individual slices of tissue, one at a time. The gradient in the magnetic field can be varied to collect the MRI of different slices of tissue, which can then be analyzed to get a picture of what is going on inside the body.
What are auxetic materials?
Auxetic materials have a unique property when they are stretched. They actually become thicker in the directions perpendicular to the applied force. Think about this in comparison to anything else you stretch. It is really quite a strange phenomenon. This occurs as a result of hinged arrangements within the material that flex apart when a force is applied to stretch it.
And the temporal lobe?
The temporal lobe is involved in hearing, memory, and language skills.
If baking soda and baking powder are different, how can I substitute one for another?
Since baking powder is diluted baking soda with acid. If your recipe calls for powder but you only have soda, you'll need to use less, but add an acid. Generally the ratio is 3 parts baking powder equals 1 part baking soda with 2 parts cream of tartar, or another acid substitute.
What makes paper towels absorbent?
Paper towels are composed of cellulose fibers, which are polymers that contain many sugar monomers. These sugar monomers can interact strongly with water molecules, which is what makes paper towels so useful for cleaning up when something gets spilled.
What is the Presidential Green Chemistry Challenge Award?
These awards were created in 1995 in an effort to promote and recognize innovation in green chemistry in the United States. 5 awards are given each year to individuals or companies for work in green chemistry in the following categories: academic, small business, greener synthetic pathways, green reaction conditions, and designing greener chemicals. Away from individual companies and placed it on the government agency. These laws received criticism for not incentivizing research and education regarding green chemistry in the industry. Due to widespread opposition to the initially proposed regulations, the implementation of this initiative had to be postponed at least once due to the need to rewrite the proposal.
How is the concentration of a solution defined?
The concentration of a substance is the amount of that substance in a solution divided by the volume of the solution. Chemists typically use molar concentration, moles of material/volume.
What is a cross-linked polymer?
When a bond is formed between two polymer chains, and technically not at the chain ends, the product is called a cross-linked polymer. Creating linkages between chains usually increases their viscosity, so more like molasses than olive oil, and creates elastic properties like those found in rubber bands. At higher levels of cross-linking, polymers can even become stiff or glassy.
How is coffee decaffeinated?
Consider the chemistry required to decaffeinate coffee. Most techniques use an extraction process to remove the caffeine from the green coffee beans before they are roasted. One method starts by steaming the green beans and then rinsing them with an organic solvent, usually dichloromethane, to pull the caffeine molecules out of the beans. The other method uses supercritical carbon dioxide to extract caffeine. The latter obviously avoids the use of toxic solvents, but is energy intensive. With all extraction techniques, it is challenging to only remove the caffeine and not the flavor compounds that we want to taste in our coffee.
Why did Edwin Madison Macmillan and Glenn Theodore Seaborg, both United States, win the Nobel Prize for Chemistry?
for their discoveries in the chemistry of transuranium elements. All the way back in 1934, Fermi discovered that heavier elements could be created by bombarding heavy elements with neutrons. Macmillan was the first to succeed in demonstrating the existence of the transuranium elements, which are the heaviest elements on the periodic table. Seaborg expanded on this work, discovering a whole additional row of the heaviest elements on the periodic table.
What does hydrophobic mean?
A nonpolar molecule that does not interact with water.
What is an electrolyte?
An electrolyte is a substance that contains ions, charged particles, and is capable of conducting electricity. Most often this is a solution containing dissolved ions, like an aqueous solution of sodium chloride, which contains Na and N-clions. The presence of ions in the solution is what makes it capable of conducting electricity. It's for this reason that it can be dangerous to get the electrical outlet wet when drying your hair in the bathroom. Pure water itself doesn't conduct electricity, but in practice, there are almost always some ions present, making tap water an electrolyte. Another place electrolytes are important is in living things. Fluids in the human body, and in other organisms, contain free ions and are thus electrolytes. Gradients in ion concentrations in cellular fluids are often important for regulating cellular processes and bodily functions such as muscle and nerve activity.
What is natural abundance?
Relative abundance of different isotopes of an element found on Earth, i.e., not produced in a lab.
What is a general chemical equation for a combustion reaction?
A combustion reaction involves the burning of a hydrocarbon in the presence of oxygen to form carbon dioxide and water as products. A specific example would be CH4 plus 2O2 CO2 plus 2H2O in general. The equation for a combustion reaction will look something like hydrocarbon plus oxygen equals carbon dioxide plus water.
What is group theory and how is it useful in chemistry?
Group theory, in the chemistry sense, involves making use of the symmetry of a molecule to better understand its physical properties. By examining the symmetry properties of a molecule, it can be placed into a point group that describes the symmetry operations. Rotations of reflections, that characterize the molecule's symmetry. Group theory allows chemists to understand an impressive number of molecular properties, including the spacing of energy levels of the orbitals in a molecule, the symmetry of the molecular orbitals, the types of transitions that can occur, like vibrational and electronic excitations, and what the delocalized vibrational motions of a molecule look like. It is very impressive that symmetry can tell us so much about molecules without the need for any complex calculations.
What is an ohm?
Zero, the SI unit used to describe electrical resistance.
What is an electron transfer reaction?
It's just what it sounds like, a reaction that involves movement of an electron from one species to another. This most often means the electron is moving between two different molecules, although intramolecular. One molecule, electron transfer reactions are also encountered commonly in the study of chemistry.
What are the basic units of length?
Almost every length scale used in science is based on the meter. Chemistry frequently deals with very small lengths, so while you're probably familiar with millimeters, 10 to 3 m, it's hard to have an intuitive sense about just how small a nanometer, 10 to 9 m, is. There's another length scale commonly used when talking about chemical bonds, the angstrom. An angstrom, A, is 1/10 billionth of a meter, 10 to 10 m. The lengths of chemical bonds vary depending on the elements and other factors, but are usually around 1 to 2 a.
What is a geometric isomer?
Geometric isomers are molecules containing the same set of atoms and bonding arrangements, but with a different spatial arrangement of the atoms or groups. For example, cis and trans isomers are an example of geometric isomers.
What nutrients do plants obtain from the soil?
There are 13 mineral nutrients that plants obtain from the soil, and these are divided into the categories of macronutrients and micronutrients. The primary macronutrients include nitrogen, phosphorus, and potassium. Plants require these primary macronutrients in relatively large quantities and deplete them from the soil more rapidly than others. The secondary macronutrients include calcium, magnesium, and sulfur. Micronutrients are required in smaller quantities than the macronutrients. and these include boron, copper, iron, chloride, molybdenum, manganese, and zinc.
What is a polymer?
A chain molecule consisting of a repeating series of a single unit, or possibly multiple repeating units.
How do painkillers know what part of the body to target? Or phrased another way, why doesn't your whole body get a little numb when you take a painkiller?
Let's limit this discussion to what are called non-steroidal drugs, like ibuprofen. Ibuprofen, and other drugs like it, work by interrupting the series of signals that your body uses to communicate pain to your brain. The COX, cyclooxygenase, family of enzymes play an important, but intermediate, role in this pathway. This means that the COX enzymes take one type of signal and convert it into another that your body recognizes as pain. By working on an intermediate messenger, ibuprofen only takes effect where the pain is occurring. That first signal has to already be there, so your whole body doesn't get numb when you take ibuprofen.
What is a polymer?
Polymers are large molecules, usually made up of smaller repeating units. The word itself, polymer, means many parts in Greek. You probably started thinking about plastics, like milk jugs and plastic cups, when you read the title of this chapter. Plastics are common examples. But polymers also play important roles in all plants and animals, including you.
Where does rubber come from?
Rubber trees. No kidding. Natural rubber is collected from rubber trees, like maple syrup comes from maple trees. Except the syrup is latex sap. It's a polymer of isoprene where each carbon-carbon double bond along the chain has cis stereochemistry. Although there are man-made alternatives produced artificially. Even today, about half of the rubber produced each year on our planet does come from rubber trees.
What are pigments?
Pigments are molecules that selectively absorb particular ranges of wavelengths of light. The remaining reflected wavelengths are the color that you perceive the pigment to be. So pigments can only subtract wavelengths of light from the spectrum. But they cannot generate their own light. For example, a blue pigment absorbs red and green light, but reflects every other color. Alternatively, the blue pigment might only absorb orange light, which is the color complement of blue.
How are polymers different than small molecules?
So many ways. Polymer chemistry and polymer physics are big areas of research both in the recent past and today. Because connecting a bunch of small molecules into one big one results in lots of interesting changes. To give you a metaphor, let's talk about pasta. Start with uncooked macaroni and uncooked spaghetti. If you try to move your hand through a bowl of uncooked macaroni, you won't have much trouble. But if you had spaghetti noodles all lined up and you tried to move your hand through them, in either direction, you'll run into problems. You either need to break the noodles, or you need to carefully thread the noodles through your fingers. Both of these actions require energy, enthalpy in the first case and entropy in the second. Now let's cook those noodles. Stick a fork in each of the bowls and spin it around. With macaroni, nothing happens, but the spaghetti starts to wind around your fork, gets tangled up, and so on. Macaroni, a collection of small molecules, noodles, is totally different than polymers. Spaghetti, which are also made up of flour and water, but are much longer. The raw and cooked spaghetti aren't just easy to imagine. They're great ways to think about polymers in different states, solids and liquids, glassy states, and polymer melts.
What is a barometer?
An instrument used to measure pressure.
What is radon?
Radon is an element that is widely known for its potential to cause cancer. It is the heaviest gas known to man, with a density roughly 9 times greater than that of air. It is usually found in soil and rocks, though it can also be found in water. Fortunately, radon detectors are commonly available that allow you to test your home for elevated radon levels.
What are colligative properties?
Properties of a solution that depend on the amount of solute dissolved.